Welcome to Access Control, a podcast providing practical security advice for startups, advice from people who've been there. Each episode will interview a leader in their field and learn best practices and practical tips for securing your org. For today's episode, I'm chatting to Nikhil. Nikhil is the site manager of the Berkeley Open Compute Facility. The OFC is a student-run organisation and provides access to compute resources and has been around since 1983. I recorded this podcast in person, and I'm still getting my on-site recording dialed in. Welcome, Nikhil. Thanks for joining us today. Can you tell me a little bit about yourself?
Hi, I'm Nikhil. I am the site manager for the Open Computing Facility. So that kind of means I decide the technical direction of the organization, what services we provide, and more importantly, I guess, for my role, is how we provide those services. What compute resources, how do we keep all those compute resources secure and accessible? And I've been bouncing back and forth between this role and the general manager role, which is more of an administrative, dealing with the school bureaucracy and things like that.
And how long has the OFC been around?
The OCF has been around since, I think, 1983, somewhere in that range. So it's been around for quite a while, the early ages of the internet.
Obviously, we're in Berkeley, and you're in the computer science program. We were just talking before this. There's some prominent computer scientists in Berkeley. And if you know any projects or interesting things that have happened.
Yeah, OCF is actually where the GNU image manipulation program was created. And also VI was created at Berkeley. So quite a few notable software projects have their roots kind of starting for here. An anecdote that I like sharing is that the file format for GNU image manipulation program is .xcf, and that's because the OCF was actually created out of something called the Experimental Computing Facility, which was XCF.
Oh, very cool. So what did people do before? I mean, I guess in the 80s there wasn't much computing resources available or servers. Was that why it was created?
Yeah, pretty much. People needed a place to check their email, if email was even a thing there, or have access to a bulletin board or whatever. And they didn't necessarily have a computer at home or even in their pocket. There's an email chain that we have saved somewhere in the OCF where it's they were threatening to shut the OCF down because of a lack of space. And there was just an outpour of support where it was I cannot check my email. Bad things are going to happen if the OCF is closed.
And it's an all student run and orchestrated body?
Yeah, we get funding from the university as well as the ASUC, which is our student government. And we use those funds entirely student run. There's no paid staff involved here. We maintain all the infrastructure and provide useful services.
And I think I became aware of it. I was doing a weekend Raspberry Pi project, and I saw that the mirror that it picked up was one of the OCS mirrors.
Yeah, mirrors are funnily enough, one of our largest recruiting pipelines, kind of, because students who come to Berkeley and are already using Linux and they are looking through the list of mirrors on their distribution. Sometimes they see ocf.berkeley.edu and they're oh, what's this? And they'll come check us out.
And then for people who sort of aren't that familiar, can you just sort of describe what the service or what do mirrors do?
Mirrors, basically, people write open source software and they need to distribute binary versions of those open source software so people can use them without having to compile everything. And the way that distribution happens is they compile it once and upload it to their server, but there are many people around the world who need access to the software. So a bunch of people donate their bandwidth basically by making a copy of the upstream mirror and then, or the upstream place where all the binaries are located. And then people who want the software, instead of going to all go to one server, they'll go to their nearest mirror, which for people in the Bay Area is often the OCF.
And do you have your own IP space as well?
Yeah, we do. It's a fairly small /24 v4, and then we have a /48 v6.
That's pretty cool. And then bandwidth, this is on the university network?
Yeah, so this is a fairly recent project where our main uplink is actually only gigabit because we like keeping our servers in our computer lab, which is an active student union space where there are a bunch of students walking around and stuff. So that only has gigabit uplink. But recently we managed to get our servers into the campus data center where we take advantage of their 10 gig uplink.
Great facility to have. You run lots of open source software. I know you're GitHub, OFC, you have all of your projects there. Can you say one of some of the core services that you run?
Most of the software that we write these days is dog fooding for our own infrastructure. So not a whole lot of use outside of that. Some of the projects that I'm particularly excited about are Transpire, which is our Kubernetes helper library. Basically, what it lets you do is you can plug in your own CI system, you plug in your own secrets management system, and then some config generation system, which you can either do entirely in Transpire through a Python domain-specific language, or you can plug in existing Helm charts and other config generation things that exist into it transparently. And it just combines all of these and makes sure that the state of a Git repository is the state of your Kubernetes cluster. And as far as I know, there's nobody that actually like bothers to combine all the different possible things and like give you a nice packaged, all of your config goes in one place type thing. So that's pretty cool.
Use the like Argo CD pull, but I guess it misses secrets and other aspects of it.
Yeah. See, Argo CD solves like the one specific problem. Actually, the way we have it set up right now is that for CD, we actually shell out kind of to Argo CD, and that takes care of diffing the cluster and making sure the YAML that we have in a repository is the same as what's in the cluster. But kind of the magic of Transpire is that you can just replace that with whatever you want, and you can have an entirely different system for config management or an entirely different system for CD. And in theory, it all works. But we're currently the only user, so.
But it's available and it's on GitHub.
Yep.
And then I know Teleport is another project that you run for accessing infrastructure. Can you talk about like why you initially reached out to use Teleport to access your infrastructure?
Actually, it started when UC Berkeley decided that SSH would no longer be allowed if the SSH access was password only. It must have, like be password plus 2FA or SSH keys. And we have a large user base of people who probably wouldn't know how to set up an SSH key, even if we gave them documentation. I mean, they're not going to run like SSH key gen. And then we also need to build some system for like adding SSH keys. And either way, like two-factor authentication is probably something that's what we want.
And then what were those people doing on those boxes?
Yeah, people need to access these boxes to access like their files or like update their website, for example. So yeah, there's a lot of use on this and a lot of people picking really bad passwords. And a lot of emails from UC Berkeley security saying your website is compromised. And we're like, we know, well, it's not our website, it's our users' websites because they use bad passwords and have outdated WordPress and so on.
So that's like a service that you provide if anyone wants, it's kind of like a virtual hosting, I guess you can
Yeah, it's virtual hosting. It's pretty much like your typical like LAMP stack web host. People, like 99% of people just do WordPress, but we also offer like actual containerized application hosting for people who need that.
People were on the journey of replacing, well, you were saying passwords aren't good, and then you're like, what are the other options?
Yeah.
How did sort of Teleport solve that access problem?
So Teleport kind of just has two-factor like out of the box because we can plug it into our authentication system, and our authentication system already has 2FA. That was very nice out of the box. Other features that turned out, like they were not the reason that we like initially wanted Teleport, but they turned out really nice, were the audit logging capabilities. We haven't needed them for security yet, but just because like, oh, what did I type in last week? That is something that you can do by looking at an audit log. Another feature that we really like is like collaboration. Whenever we're working on infrastructure, like having multiple people access the same shell without messing with the TMUX shenanigans is actually also very nice.
And then what are some of the other infrastructure concerns you have?
I think I kind of alluded to this slightly earlier. People having outdated WordPress. We need to make sure that they don't get compromised websites, but at the same time, we want to give them control over their own WordPress. So it's kind of like a fine line between like, oh, we're just going to automatically update and break your website, and also we need to give you some control.
For when you run mirrors, are there any concerns of like software supply chain attacks on people trying to upload a malicious package to the Berkeley mirror, for example?
Yeah, I would say there are. Our mirrors are actually isolated from the rest of our infrastructure kind of by design. I guess now they're all on Teleport, so that's Teleport is a single point of failure here.
And then are there any other concerns that you have from a security perspective? But actually, who's responsible for security?
I mean, the short answer is we are.
It's like a collective team.
Yeah. The long answer is it doesn't matter a whole lot if like one of our Linux boxes is now running untrusted code for a little bit. We like very much do not rely on trust for the user code for any of our other infrastructure. But also these are running on like UC Berkeley IPs, and those have trust associated with them, especially for accessing like academic papers. Journals trust the Berkeley IP space. So we have some tooling there to like disallow and detect that stuff so that they don't get mad at us.
Yeah, because I guess it has strong sort of domain authority in like the IP space that you can't already have. So I guess it seems like you have quite an open playground in which people can experiment, run stuff, you know, kind of like when you go to university, you know, it's like a place to experiment and maybe break some stuff, but within the guardrails, keep stuff pretty secure.
Yeah, I think that's like a pretty valuable thing to maintain. And it's one of the reasons that we haven't just, I mean, like the ideal situation is like, oh, we just manage everything for everyone and you click a button and you get a website, and we don't allow you to run any of your own code. And that's like probably a lot better from a security perspective, but that's not really the the problem we're trying to solve.
Yeah, because people, you gotta learn on your LAMP stack. You can get a long way with some very questionable PHP.
A lot of people writing very questionable PHP and hosting it at the OCF.
Yeah. You also were going through a migration process from a legacy stack to Teleport, and I think this was also to do with the mirror. Can you talk about the benefits you've gained during that transition from your legacy stack to the new one?
Deploying Teleport was actually really simple, so that wasn't an issue. The hard part here is that we didn't already have two-factor on all the user accounts, so getting, I guess, like 65,000 active accounts and like many hundreds of thousands more active accounts going back, or hundreds of thousands inactive accounts, getting them all on 2FA or like finding a way to disallow that is the actual hard problem. And I guess where mirrors comes in as like why Teleport was useful is the mirrors box now runs on a different subnet from our primary subnet. And a lot of our infrastructure is hard-coded to assume that machines will be on our primary subnet. And that includes all of our like SSH infrastructure. And kind of we don't need to worry about that when Teleport is the SSH infrastructure.
So a little bit of like network isolation.
Yep.
Just to go a little bit deeper in with the migrating people from like a second factor or in like inactive accounts. I think this is an interesting problem that many sort of organizations face. And I think we've sort of seen the phases of like people start with like maybe like SMS, then it's like short token, then it's YubiKey.
Right.
And sometimes it's like opt-in, or maybe it's like a biometric, it's like Touch ID. For the inactive accounts, like, did you have like a grace period, or what was sort of the enrollment to these like different sort of technologies and the pros and cons of them?
So we have trusted endpoints. So those are like our actual physical machines. We figure like chances are nothing bad is really going to happen if someone is like physically in the lab and is logging in on a computer. So we're not bothering with 2FA for now. YubiKeys are also never going to happen because we provide the service for free with a very, very tiny budget. And we couldn't like give people YubiKeys, and they're also not going to buy their own. SMS is also out of the picture for the same reason. Like we have to pay like Twilio or some company to send out those two-factor codes. So kind of what we've settled on is just like your typical like Google Authenticator or like email-based 2FA, which is like almost not 2FA because you can also reset your password. So it's kind of 1FA again. But the benefit with that in our specific case is all the emails are Berkeley emails, and those emails have a 2FA thing associated with them already via Duo that the university pays for, and we don't have to worry about. So it's kind of 2FA, and we'll take it for now.
And does alumni get access to you, or is it just current student?
Yes, alumni also get access. So it's an entire other set of challenges because they're not actively subscribed, and they'll like log in once every like 4 or 5 years and just be like, they'll be confused when things are different. But we'll deal with that problem when we get there.
On the point of the computers in the room being heavily trusted, I know Coinbase for a while had a SSH room, and they had like a heavily protected room that you could go into that had like super admin privileges with cameras.
That's interesting, yeah.
All these like different combinations of how do you get like access to systems, and different like physical security too can also like help increase it. I mean, there's always the case someone can always walk to a server rack and get access to it.
Yeah, I mean, there's nothing like extremely high security that we're protecting here. It's just random files and websites. So
how do you prioritize some of the technology services that you offer to the community, and sort of what factors influence the decisions about what you're going to support next?
So I guess historically, like the purpose of the OCF was like, here's a place where you can come check your email, come visit messaging boards and whatnot. And those days are long gone now. Everyone has multiple computers. Both of us have computers on our wrists right now, and at least like one in a pocket, one on the table. These days, I think the kind of the technological niche of the OCF is like kind of a playground for students to like get exposed to technology, even if they're not necessarily like because they're CS majors, just because like you are going to have to use many computers in your life, and understanding how they work on a deeper level, even if it's just playing around with a computer, is probably very valuable. So that's one of the technical directions that we go in. And the other technical direction that we want to go in is like providing more useful services. Kind of like the era of like you need a website is like probably almost over. I think most people are on platforms like Facebook or Yelp or whatever, and they don't actually need to make like a website. So like website hosting is like increasingly less relevant even. Finding useful services, like for a while we hosted Mastodon. We actually shut that down like the week before Elon Musk bought Twitter, which was like extremely unfortunate timing. We might bring it back. Also like chat through Matrix, things that people can actually use even if they're not that popular.
You say you have a high performance computing infrastructure to people run like AI or CUDA jobs?
Yeah, most of the users of our high performance computing are actually not like our AI labs at Berkeley. Like they have their own racks upon racks of DGXs or whatever they use for AI stuff. Kind of like the people that we serve with our HPC infrastructure are like the physics lab that kind of is just doing like their first AI project, or like a bio lab, and like everyone needs some kind of AI thing these days. Also, unsurprisingly, like a lot of the people at the OCF who are volunteer staff here are CS majors, so we know a lot about how like CS courses are run, and we try to help them out when possible. One of the things that they're running into right now is that they also need 2FA, and they don't have it, so everyone has to connect to a VPN and then do password SSH from there, and it's a whole thing because the VPN software doesn't work on Linux, and yeah, it's terrible.
Yeah, I can imagine actually doing this like multiple hoops to sort of just get your assignment done. It can be, I'm sure, like frustrating. How do you see the role of the OSC evolving in the future, and sort of what else new initiatives and projects you're excited about?
So I think this could go like one of two ways, and the correct answer is like it depends / both. Like the first way is we start providing like more technical services. Like we could theoretically provide virtual private server hosting for people who just want a Linux box and they want to do stuff on it. Also like more advanced container hosting, that kind of stuff like basically that a cloud provider would typically provide, except for free to students. The other direction is like more user-facing services, kind of the stuff that I talked about earlier, like Mastodon or Matrix or things like that. So yeah, the correct answer is probably a little bit of both, depending on how hardware donations go for like certain companies that are considering like giving us hardware. Again, we don't have a very large budget, so we rely on that, things like that. Depending on how those go, we can probably just do like all of the above.
Yeah, sort of student-led, to see what is sort of impactful and what's sort of interesting for the students to run. One
of the reasons that we do things is for the people who are running it, like me and the other volunteer staff, to get exposure to computer infrastructure. So sometimes even if something is like way overkill and just really complicated, it's like we might as well do it because of learning.
Yeah, it's a good time to do it. And so after your time at Berkeley, what are you sort of looking to pursue next?
I think I'm interested in computer infrastructure, and I will do something in that space. Past that, I'm not sure. Maybe more school. I don't know.
Yeah, it's an interesting compute infrastructure. I think we're having this like reemergence of it in the industry. So we had like the movement of consolidating on like VMs and then to the cloud, and now we're sort of seeing the reemergence like back into like people's data centers, back to edge, back to like smaller embedded devices. I mean, like a self-driving cars, like a supercomputer on wheels with all those like sensors attached. To like the concept of like what is infrastructure is a much broader term than the big blue IBM in your basement.
Right. Yeah. Pretty much anything can constitute infrastructure, and I think that's like pretty exciting.
Yeah, definitely. I agree. As a company provides access to infrastructure. We always like to wrap up the podcast with one last question. What's one practical advice you'd give to other university labs and startups to improve access controls?
I have almost like a joke answer for this question, which is like actually have like access control to begin with. I think like for a lot of like lower end, like your typical like small lab of like 10 people or like groups like us, kind of the ACL is like you have all the permissions or like you don't have any permissions. And I think there's definitely like something to be gained by putting a tiny bit of effort into segmenting access control in that way. For example, like you could have undergrads with less privileges than graduate students, or even like past that, like not all graduate students need full root access. Maybe you request it on a per time basis, that kind of thing.
Yeah, just some basic access control is like a good place to start. This podcast is brought to you by Teleport. Teleport is the easiest, most secure way to access all your infrastructure. The open source Teleport access plane consolidates connectivity, authentication, authorization, and auditing into a single platform. By consolidating all aspects of infrastructure access, Teleport reduces attack surface area, cuts operational overhead, easily enforces compliance, and improves engineering productivity. Learn more at goteleport.com or find us on GitHub, github.com/gravitational/teleport.